Now, this question is about the motor. You can able to see there is a coil here which is supposed to rotate within the magnetic field of the bar magnet. So for this case here, magnetic field originated from the north towards the south. We have a power supply here, that is a positive terminal and negative terminal. For this case here, conventional current will flow in this direction through the split ring. So this particular part here, so current flows in that direction, and then it comes back in this direction here. One of the common question before we look at this diagram here, someone may ask you, what is the purpose? What is the purpose of the split ring? This is the split ring here. The split ring commutator, the split ring commutator, it helps in keeping, so it keeps the coil, this coil here, it keeps the coil rotating in the same direction, And how does it achieve this? By changing the direction of current, by changing the direction of current in the coil every half cycle. So that is the purpose of the commutator. And then remember, a motor, the work of a motor, it converts kinetic energy to, a motor converts electrical energy to kinetic energy. So the electrical energy to kinetic energy, that means that is why there is a power source. So the moment you see a power source, know that that is a motor. Now, on the figure 9.1, draw a pair of arrows to show which way the coil rotates. Explain the direction you have chosen. Now, we have already indicated the direction of the current, conventional current. And for us to do this, we are going to apply the Fleming's left-hand rule. And the Fleming's left-hand rule states clearly that when the first finger, second finger, and third finger are mutually at right angle, then what happens is that if the first finger is pointing towards the direction of the field, second finger points the direction of the current, then the thumb will always point the direction of the force, movement, or deflection. So for this particular case here, I want to concentrate on one side of this coil here. Let's concentrate on this side here. Now for one side, for this case here, you can see current is flowing. You see, this is the direction of the current, and is here, this is the direction of the current. And then north to south, the direction of the field, north to south. And we expect that this particular point here to be deflected, to have an upward displacement, while this particular point here to have a downward displacement. So that's the direction of the force. And then, of course, you'll be told to label it F. So it means it will be rotating in an anti-clockwise direction. Now, why have we chosen this? So what the examiner should, by indicating the direction of the current, so we can just say that, so we can label this at maybe this part here. So the coil, the side, so current flows towards the split ring, that is on the side of the south pole, the one that is close to the south pole. So by using Fleming's left hand rule, then the side of the coil will experience a force acting upward. Will experience a force that is acting upward. Now on the figure 9.1, draw an arrow to show the direction in which the electrons flows through the coil. Now conventional current flows from positive towards the negative. Electrons will flow in the opposite direction. So in the coil, this opposite one shows the direction of the electron. Explain why the electrons flow in the direction that you have shown. I've already indicated that electrons flows in the opposite direction to conventional current, or you can just say towards the direction of the current. So that is that. And then there is part B of this question. Now part B, state any difference each of the following changes makes to the rotation of the coil in the figure. Now Roman 1, changing the polarity of the power supply to that shown. So if you look at the initial one, the polarity here, this is positive. Now it has been changed. So where there's positive terminal, we now have the negative terminal. So what will this one happen? So this will change the direction of rotation of the coil. Now that for the first diagram, we have said that it will be rotating in anti-clockwise direction. So for this case, you can also just mention that it will rotate in a clockwise direction. That is also acceptable. Changing the coil to the new coil as shown. So instead of having instead of having a coil with 1 turn, now it has increased the number of turns. So when you increase the number of turns, this is one of the factors that affect the strength of the force experienced by or the turning effect experienced by the coil. So this will increase the rate of rotation or the speed at which the coil rotates. Another factor, there's another factor also, using a stronger magnetic field. Using a stronger magnetic field will also increase the speed of rotation, the speed at which it rotates.